For day 5 and 6, I made a Pentaflake, which is a type of fractal. I really stumbled my way through this. Just kind of brute forced it. We'll do some investigation into what's going on down here later. But first, here's a zoom into this primitive plane with a fractal printed on it. This is an actual zoom in on this plane with the camera in Blender down to the point where we start getting floating point precision errors. To look at the nodes, I've reduced it down to just what needs to be here. We're using generated coordinates. We're doing a pretty standard set of operations here to turn it into something that looks like object coordinates. And then inside of this coordinate group here, taking a gradient, dividing it up into fifths, inverting it, and then for that reason, the way this math works out, I need to subtract 0.2. And then we're multiplying by 2 pi. And we're using that to drive the angle on this vector rotate. And I expose the values for that out here. I don't think I ever ended up using them, though. So, basically, we're basically going to walk the coordinate space out a certain distance, 0.5 meters, and then rotate it by 36 degrees, which is... I don't really get it. And if we view it through my shape viewer here, we see we get the wrong thing. We actually just duplicate this coordinates node group again and place it in the middle here. Then we get 5 pentagons. Like I said, I stumbled my way here, so there was a lot of trial and error before I even got anything remotely resembling something that I could work with. My shape viewer just takes the incoming vector and turns a linear gradient out of it and runs it through a compare with an epsilon that we define. I've defined it to be half of the distance that we're walking our mapping node out each time. Doing iterations beyond this is a little bit weird. Basically, we're going to duplicate these last 2 nodes and place them after the entire group, which produces its own kind of interesting pattern. Actually, if we scaled this out a little bit, if we continued this, you would see this is also a repeating pattern. Kind of neat. But we need to make a change here. And usually I can dial these numbers in. I was getting pretty close, but I was noticing that the number just felt familiar. And so I Googled it, and it was familiar in a way. the number I was arriving at is actually 1, the default scale, plus this number right here. We can copy. So 1 plus the golden ratio. And that mapping node needs to be replaced as well. But now you can see what's happening here. So I was pretty excited to find that. And especially something that really doesn't involve any crazy math. You know? Most of the work is done by a gradient texture. Anyway, I'm continuously amazed by what you can make in this crazy program while being a complete and total dumbass like myself.